Okay, good afternoon, guys. Just want to initially say I did pop the two chapters for the Pure Maths onto Google Classroom. So if you do want to access them, you can do. It also shows the parts that I kind of just jumped ahead on because they were graphs. Okay, and you'll probably notice with the quadratics, I won't go over the stuff you've already covered for IGCSE. I'll probably move on to the stuff that hasn't actually been covered yet. Okay, so that's next lesson. Today we are going to do the last part of logs, which is logs with equations. So this is the key that you need to know. So when it comes to multiplication, the division, as well as the product, that's related to the index. So it should be relatively easy to remember those. This is the one that I would probably say is the key one that you should learn. Okay. So once you've got this, solving the equation should be pretty simple. Okay, so if I was to do, say 1, I'm going to do 1a, which is 2 to the power of x, which is 75. And then all I need to do is rearrange from this format into this one. So x would be log a base to 75, which you can just tap into your wonderful calculator. Which is 6.2288 dot dot dot. Okay, which is 6.2323 significant figures. Okay, and then I'll just do f, which is 7 to the power of 2x minus 1 equals 23. Okay, so that's 2x minus 1 is log 723. Then just going to rearrange this to put x as a subject. So you've got log 723 plus 1x equals log 723 plus 1 all over 2. Okay, so x is 1.30566. Which is 1.3123 significant figures. Okay, so super easy if you have your Casio calculator. So obviously if you've got the A-level one, you've got a little bit more with that, but I do know the other ones, they have ln, they have log. If you don't have a base for log, that's just log base 10, okay? Ln is natural log, so that corresponds with E, which you see on the shift key. And then you have a log where you can type your own numbers in. Okay. So that's this one. So all of question 1 is quite similar when it comes to that. Oops, let me just pop the pen down. Okay, so for question number 2, you're just going to have to start applying your quadratic equation knowledge along with your log knowledge, okay? So what a lot of people like to visualize when they're doing this is substitution. Okay, so they've made this quite easy for you by popping it into brackets. So if I pop it into brackets, it already kind of given you the clue. So I'm going to substitute 2 to the power of x as a instead. So this will then be a squared, because if you have 2 to the power squared, it's 2 to the power of 2x, right? So I've got a squared, take away 6a plus 5 equals 0. And then if you just factorize that, you should get minus 5 and a minus 1 equals 0. This is then a equals 5, a equals 1. Instead of a, obviously I want x, I don't want a. So I'm going to say 2 to the power of x is 5, 2 to the power of x is 1. So x is log base 2 5, x is log base 2 1. Okay, you might kind of remember anything to the power of what equals 1. So it's 0. You can pop that into a calculator, but you might remember that from your index laws. If you remember that from your index laws, you should be able to do that one. Okay, whereas this one, you will need your calculator. 2.32192 dot dot dot. Okay, which is 2.32 to 3 significant figures. Okay, so that is A, and I'll just do F for that as well. So you have 2F, which is 2 to the power of 2x plus 3 to the power of 2x, take 4 equals 0. Okay, so again, they've already given you the clue, so that's A equals 2x, so that will be A squared plus 3A, take away 4 is 0, so that will be A plus 4, and A take away 1 is 0, so this would be A equals -4, A equals 1. So again, 2x equals 1, so I know x is log base 2, 1. If you want to type that into a calculator, or if you already know it from that step, that just equals 0. This one's quite interesting actually. 2 to the power of x is -4. So 2 to the power of anything is always going to be a positive number. If that was a -2, we might have thought about, okay, it might oscillate in between, but we'd still have a bit of trouble with the -4. But it's a positive number. So if I have a positive number, regardless of your power, this should always be positive. So just like we can't get into imaginary numbers, where when you're talking about like quadratics, and you have, otherwise you have 2 solutions, 1 solution, or 0 solutions, because when you have 0 solutions, that goes into imaginary numbers. And so it's usually when it's floating above or below the line, if you can remember that. In the same way, we have this, which isn't a solution that we can actually kind of compute. If you pop it into your calculator, it will probably give you something like syntax error or math error or something similar to that. This just isn't possible. I cannot have a power of 2 that would give me the -4, especially at this stage in time. So for this one, just not possible now. So not possible, therefore no solution. Okay, so for the level we have right now, we would just say there is no solution for this one, and this one is 0. So there's only one solution. So although, yes, we factorized and we've seen that there's 2 possibilities, this possibility is not currently possible. So we're just going to say no solution on this side, and this side is a 0. So there's only one solution overall. Hopefully that makes sense, okay? This isn't something that you would query over and ponder and do any extra time on. You would just say it's not a solution. I'm just going to leave that where it is, and I'm going to say this one is my solution, okay? But it's always important to note, especially when you start moving on into A-level, that you need to state they are not solutions. If you do not make that statement, it is possible that you can start losing marks, because part of the mark scheme would say that, yes, you've acknowledged that this is a possible solution, but you've also said this isn't actually possible, so it's not going to be counted as a solution. Does that make sense? Hopefully that makes sense. But that's what you need to be doing. So combining your logarithm knowledge with your quadratic knowledge, and just knowing some of the basics. So you probably know from this one now, if I have a number to any kind of power and it's a negative, that would just never be possible. Okay, so when you have logs, if I have ax equals a negative number, I'm not expecting a solution. Okay, and if I have ax equals 1, then I know x is going to equal 0. Does that make sense? Hopefully that should make sense. It's a bit like if I say ax equals a, then I know x is going to be 1. These are just those little patterns that you just start picking up once you start doing them. But hopefully you should be able to get through these 3 questions. I've already done 4 of them, so the rest should be relatively okay. Number 3 is a bit of a challenging question, but hopefully you guys should be able to get through it. Okay, and then next lesson we are going to look at another part of the quadratic equation. Okay, toodles guys.